So in this video lecture we are going to discuss about the amount of power which is transferred and how that power and torque are related. Okay, this is a quite basic formula which you might have studied in 12th grade physics or 11th grade physics, but still we need to understand this. So what is the primary purpose of the shaft? In the very first video of this series I had told you that the primary purpose of the shaft is to transfer power. So it is generated at a place and then it is transferred. It is generated at a place and it is then transferred. Okay. So how much power and how much torque and what is the relation between the two? What we are going to study in this topic, we are going to study the relationship between the torque and the power. Okay. So we know that power is given by the formula torque into omega, where omega is angular velocity. Okay. So we also know that omega can be written as 2 pi divided by time period or 2 pi f. Okay. So formula for power is 2 pi ft, where what does f represents? F represents number of cycles per second. Okay. What does f represent? F represents number of rotations or number of cycles or number of events per second. Okay. It is a frequency. F represents the frequency. So what is the frequency? What is the meaning of the word frequency? Number of events per unit time. Okay. And the here time will be in second. So it is RPS. What does F stands for? RPS, revolutions per second. So if you have in second, then this is the formula for power. The second formula which we use is power is equals to 2 pi nt divided by 60. Here n stands for RPM. Okay. So there are two formulas for power. But basically they all have been derived from the same formula, power equals to torque into angular velocity. Okay. Power equals to torque into angular velocity. Angular velocity can be written like this, and if you replace omega by 2 pi f, so it gives you a relationship between revolutions per second and power, and the third one gives RPM. Okay. RPM stands for revolution per minute. So most of the place where you transmit power, this RPM might be given and the power might be given. Okay, you may be knowing the power and you may be knowing the RPM, and based on this you have to find the value of the torque, and once you know the value of torque you can also find the value of stress and deformation produced in the shaft. Okay. So next point. Now in case if you want to design a shaft, okay, finally when you have the relationship, now you want to design it based on your requirement. Based on your requirement. So what is the formula which you have? You have T equals to, or T upon J equals to tau upon rho. So T can also be written as J divided by R multiplied by tau max. Okay. So by using this formula you can try to design this shaft. Let us now understand. The maximum stress, this is going to be at the surface. Okay. This will be the material property, the allowable stress. Okay. So if you know the allowable stress and if you know the torque, which the amount of load which you are going to give on the shaft, by finding this you can find the diameter of the or radius of the shaft. Is that okay? So let us see. What is J? J is pi r raised to the power 4 upon 2 or pi d raised to the power 4 upon 32. You can use either of the two. And if you use r, J by r can be written as pi r cube divided by 2, or if you write in terms of diameter, it will be pi d raised to the power 4 upon 32 multiplied by 2 by d, and this value will be equal to pi d raised to the power 3 upon 16. So this is what I am trying to tell you. Maximum stress which the material can sustain is the property. It is the property, means the proportionality limit divided by factor of safety. Okay. So you can get this from the data book. Based on the amount of torque which you want to transfer, and how will you calculate the torque? The torque will be calculated from the power transmission and the RPM. So if you know the power transmission and the RPM, you can calculate the value of torque, and once you know the value of torque, and you can get this value from a data book or from it may be written in the question, so you will be able to find this value J by R, and if you know the value of J by R, you will be able to find the value of diameter. So if you want to design a shaft based on the strength, then this can be the formula. This is the formula. Is that okay? So I hope I have explained. You have tried to understand this and use it. Okay. There can be certain situation where you want to design based on the deformation also, that you don't want the shaft to twist to a certain limit, beyond the certain limit. So you can use the next part. Okay. If you don't want to the shaft to go beyond certain limit, the angle of twist should not be more than that. Okay. So you need to use this formula, P by J equals to G phi upon L. See, G is the material property. If phi by L is defined, then you, based on the power and RPM, you can find the value of torque. And once the value of torque is known, by using the value of J, by calculating the value of J, you can find the value of radius or diameter of the shaft. So if you want to design a shaft, this is where you have to land upon. There are two portions. So if you want to design, then you can use this formula, torque is equals to J, G phi upon L. This and this are defined. G is the property, phi by L is the limit given based on the problem, that how much twist you want to give. And if this is fixed, and if you know the value of torque based on the power and the RPM, you can find the diameter of the shaft. Okay, so this is the design part. Now, the most important thing which you have to understand, because these are the questions which are asked, these are the topics on which questions are asked. One very important topic is the derivation, which I have discussed earlier. Okay. Now these are the interpretations, the questions which can be asked from derivation. So how can you find the angle of twist? So if you want to find the angle of twist, what is the relationship? T divided by J equals to G phi upon L. So if you want to find the angle of twist for a given load, then it will be given by TL divided by JG. What is this? Angle of twist. This is the deformation produced, the angle of twist. Is that okay? So if you want to find the angle of twist, what you have to do, you can use this formula. Remember, these formulas have been derived with basic means concept that the area of cross section remains constant. Okay, the area of cross section remains constant. If the area of cross section varies, or if the torque varies, in that situation the angle of twist is found by using the formula Ti Li by Ji Gi, where all these things are dependent upon the portion on which this torque is applied, the length of the shaft for which the torque and these are known. So angle of twist for a shaft in which area of cross section is constant, and if area of cross section is not constant, or the torque is not constant in both the cases, or the material property changes, then in that case the value of phi can be found by using this equation. We can also go for the differential one in case if you are having a continuous variation in the dimensions of the shaft.